Good morning, dear students. Today we're going to learn about periodic table. Let us first talk about the ionization potential. Ionization potential is the minimum amount of energy required to remove electron from the outermost orbit. That electron which is loosely bound to the atom. In order to understand the very concept, let us see two cases. Here are the two atoms, atom number 1, atom number 2. Atom number 1 consists of one electron and one shell. Alright, so the amount of energy required over here would be E. And if we provide E energy to this electron, this can be moved out of the shell. And it can go like this, out. Similarly, we can see over here the second atom which contains two shells. You can see over here shell number 1, shell number 2. So the amount of energy required would be E1 and E2 respectively. Now we can understand, since the distance from the nucleus is closer to the first shell, therefore what will happen? More energy will be required to remove electron from this shell. Why? Remember about the electron nuclear energy. Remember, the nucleus will be pulling this electron more strongly than this one. So as a result, the more energy would be required for E1, or the magnitude of E1 should be greater than that of E2. Now let us discuss something unusual thing about ionization potential. The unit of ionization potential is electron volt. Please do remember, the unit of ionization potential is electron volt. Now what are the different factors on which it depends on? The first one, atomic sizes. Alright, because remember, let's see for this case how atomic size influences ionization potential. Now in the present diagram you can see that there are two atoms once again, A and B. Now the atom A is of a smaller size and that of atom B is of a bigger size. Why? How can we say? Here I have only drawn the outermost orbit. I have not drawn the inner orbits. But remember, the size of the atom is smaller in this A and bigger in case of B. As a result of this, what happened? What we have learned earlier, that since the size is very small, more powerful, the nucleus will be pulling out the electrons more powerful, whereas in this case it will be not that powerful at all. Thus, size of an atom influences the ionization potential. You can see over here, smaller size of A means electron is more closer to the nucleus and hence it experiences more nuclear pull, whereas B experiences lesser pull than A. The second factor that influences the ionization potential is nuclear charge. Remember once again the same thing, as the size decreases, nuclear pull or nuclear charge increases, and hence ionization potential also increases. When the size decreases, what will happen? The nuclear charge decreases and ionization potential also decreases. Now what happens when we move across a period, that is from left to right? You can see over here, we are taking period number 2 as an example: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Alright, so under that situation we can see in each cases ionization potential is given. You can see that in each cases it's increasing as we move from left to right. Now the question arises, why does it increases? It increases for the very same reason, that as we move from left to right, the size keeps on decreasing. Why so? Because the nuclear pull becomes more and more powerful. Thus we can say that ionization potential increases across a period from left to right. Same thing we can see in case when we take example of group number 1. We can see lithium, sodium, potassium, rubidium, cesium, and we can see ionization potential given over here. And when we see over here, we see it keeps on decreasing as we move down the group. Now why is this so? Once again, the atomic radii increases. Why? Because the number of shells keeps on increasing over here. Second thing, nuclear charge also increases, but it is not that powerful because the size is much bigger than that of atomic nuclear charge. So therefore, ionization potential decreases when we move down the group. Continuing with the same idea, let us understand electron affinity. Alright, it is also called as electron gain enthalpy. Now, as the name suggests, gain, therefore here energy would be released. Alright, let's talk about this thing. The amount of energy released while converting a neutral gaseous isolated atom into a negatively charged gaseous ion by the addition of electrons is called as electron affinity. Now, what does it actually what happens over here? The actual thing that is happening over here is whenever an atom is accepting one electron, you can see over here an atom X is accepting an electron E to become negatively charged. In order to do so, it releases huge amount of energy. This release of energy is named as electron affinity, and we can see over here unit of this is electron volts per atom, or simply electron volt will also do. So once again we'll talk about the factors affecting the electron affinity. We can understand again the same reasons will work over here, that is atomic size. As the size keeps on increasing, electron affinity keeps on decreasing. Why so? Because electrons will not be accepted by the atoms that easily. But when the nuclear charge increases, electron gain enthalpy keeps on increasing. As a result of this, what happened? Whenever it is more readily is going to accept electron. Similarly, when we move across a period, what happens? You can see over here from negative 0.61, 0.3, 1.25, you can see it keeps on rise. Alright, increases. Electron affinity keeps on increasing. Alright, now why is this is so? Atomic radii decreases, nuclear charge increases. Now do remember, neon has electron affinity 0, since inert gases are have stable electronic configuration and find it difficult to accept electrons. What about when we talk about electron affinity over here? It keeps on decreasing. 3.6, 3.8, 3.5, 3.2. Alright, when we move down the group. Alright, the same reason also dominates over here, what we have learned in ionization potential. So do remember, in case of both ionization potential and electron affinity, we can find the electron affinity and ionization potential decreases down the group and increases across a period. Thank you. Thank you for today. Tomorrow we'll learn about electron negativity and other factors that are still remaining. Thank you, students.